Okay, class, let's go over some of the problems here in lesson number 1. I'm going to be doing set 2 problems, which are similar to the ones that you'll be doing in set 3. I'm going to just go over some of the examples to give you an idea how to work these problems out. We'll be doing this throughout the year. So let's go ahead and start with set number 2. We're on page number 8, and we're on number 11. It says, write a number or expression for each of the following. So we have here the sum of 10 and 7. So first off, we would want to express that as the sum. So that would be addition. So that would be 10 plus 7. Now, if you wanted to express it as a number, then of course we would just add that, and that would be 17. Now we have the sum of x and y, excuse me, x and 7. So now that would be x plus 7. Now we could not further simplify this because we don't have values for x or any particular value. So we would leave that as is, x plus 7. We have the sum of 10 and y. Again, 10 plus y. And once again, we do not have any values for y, so we could not further simplify this expression. How about the sum of x and y? Well, that would be x plus y. And as you can see, we just need to go on, do the rest of these as instructed. It gets a little more challenging. They'll have more than one term to add. So again, you may be able to either add those terms. Remember, you have like terms in some cases where you can add those like terms, but of course the variables need to remain as they are, so you would not be able to further simplify once you get to the point of the variable. Okay, let's look at number 12. So that was number 11. These are just samples. Let's see, number 12. Number 12, in the figures below, the box represents any number, and the sets of circles represent specific numbers. So we have here figure number 1, and we have, let's see, let's go ahead and draw these out here so we can see them. So we would have 9 circles, and over here we have 4 circles. And then in figure 2, so this would be figure 1, and this would be figure 2. And here we have a box, and we also have 5 circles. Now, question A asks, what addition problem is illustrated by figure 1? Well, if we had an addition problem, we know that we have 9 circles here. So for letter A, we know that we would have 9 plus 4. So the addition problem is 9 plus 4. Now you can go ahead and add them, but that's not the addition problem. So if you give me 13 as an answer, you're not really giving me the addition. So show me 9 plus 4, which is what's being illustrated in figure number 1. Well, they asked us in B, what is the answer? I'm sure most of you could add these, and that would be 13. And again, we have to pay very close detail to what's being presented and what's being asked. Okay, in the first question, it was what addition problem is illustrated, which we showed as 9 plus 4, and now we're given the answer. Now on letter C, they ask, write an algebraic expression to represent the addition problem illustrated by figure 2. So if we go over here, well, now we're dealing with an algebraic expression. Now we learned that we can represent this box, this unknown, by, let's say, the letter x. So let's go ahead and use x. And we're going to add 5 circles. So we would say x plus 5. So that would be the algebraic expression that represents the addition. Now, what is the answer to the problem if the box represents 2? Well, we would go ahead and write out our expression again, substituting 2 for the letter x. and we would have 2 plus 5, and the answer to that would be 7. Now we're asked, what is the answer to the problem if the box represents 4? Again, we simply represent the letter X as 4, and we add 5. So our answer would be 9. So again, we're taking these pictures and we're now turning them into expressions, and these become the building blocks of what you will learn further on as we begin to build equations, and the complexity of algebra becomes a lot easier to understand if we can master these basic elements. Okay, so an unknown or a variable we would have represented, say, as a letter X. We could use actually any letter in the alphabet. We're choosing to use X primarily. We use X and Y, and you'll even use Z, but you're going to also see other letters being used for different purposes in algebra. So why don't we go ahead and let's move on to number 13. Let's get a new board here. Now on number 13, excuse me, what is the length marked with a question mark in each of these figures? So if we were to take a look at each of these figures, I'll go ahead and challenge myself to at least draw the first one. Okay, we have, notice that these segments have these arrows that are pointing to a straight line that divides, let's say, the segment from the other segments. So we have a 4 here. Now these arrows basically mean that the distance from really the edge of each of these, last one is 5. So we have 3 different segments, and at the very bottom we have this big question mark. The question mark is, well, what would be the length of each of these segments if we were to add them up? So I've given you a hint already. So we would need to go to each of these segments and add them together. We would have 11 plus 4 plus 5. And if we added these together, we have 11 plus 4 would be 15. And if we add 5, the answer would be 20. So the answer to this segment, the length, would be 20. Now, as you can see through the rest of these exercises, we have very similar problems. We start using variables in the next one. So for instance, the next one, how would we represent that without drawing it? Well, I have an X and I have a 6, and all we're doing is adding them. Similarly to what we did here. Now, yes, we were able to add these together and come up with a number, 20, but in this case, we cannot further simplify this without knowing the value of X. So the answer for B is X plus 6. In the next one, we have an X and we have a Y. Again, we're simply adding them, so the answer would be X plus Y. And we have in letter D, we have 5, we have a 3, and we have an X. And once again, we simply add them. Now we can further simplify this by adding 5 and 3, and the answer then would be 8 plus X. Okay, and we have an X, we have a 1, we have a Y, and we have another one. So if we add these all together, we would end up with, let's see, X plus, let's put the Y. Again, remember in math that, or in addition, we can put them in any order. And you'll see further along that there will be certain rules for writing equations, particularly when we're dealing with exponents. But we won't go there yet. Let's go ahead and further add these to 1 plus 1, and we'll get 2, So our answer here is going to be x plus y plus 2. And the last one has an x and a y and a z. Well, I did promise you we use x, y's, and z's, huh? Well, there they are. And that would simply be x plus y plus z. Okay, let's move on to our next board and take a look. Problem number 14. Now we have in problem number 14, the figure below can be used to show that 3 plus 7 and 7 plus 3 are the same number, depending on whether the figure is read from left to right, excuse me, or from right to left. Draw boxes and circles to show that x plus 6 and 6 plus x mean the same thing. So we're going to go ahead and we know that we have circles represent the number and the box represents the unknown. So if we have x plus 6, we could simply create a figure that looks like one box, which is x, right? And then we have 6 circles. Okay, so whether we're going right to left or left to right, we can read that x plus 6 or 6 plus x are the same. And we can go ahead and represent this in letter B. We have 2 plus x plus 5. Now, we can, and also, I'm sorry, and we have also the expression x plus 7. Now we know that. So if we were to write this out, we can write it in various ways. And I'm going to just take a moment to show you again that we can write in an order, in different order, such as x plus 2 plus 5. We know that we can write these in a different order and still have the same expression. If we were to go to the original expression, certainly we can write 2 circles, we can write a box, and we can write 5 circles. If we shift everything around, we can certainly write the box and then have 2 circles, and we can have 5 circles. Okay, and this it comes a lot closer to illustrating the x plus 7 because we can see here that we have x represented as the box and we have 7 circles. Okay, and we can certainly represent it as having them all together. Okay, now the purpose of all of this is to give you a visual example of how math in how value is grouped. We can group the value such as 2 and 5 as we did here. We took these two. Oh, that looks like a smiley face almost, huh? I guess not. We're not supposed to do that. It's class time. But we can take that value and we can add it to this value by simply shifting it over as we did over here. We did that as well up here. Now we have them grouped and we've grouped together all of these, which represent 7 circles, or 2 plus 5. And again, just by removing that little bit of space, we've placed them all together in this value. So again, this is a visual representation of math, and that's really the purpose of what we're trying to do here in lesson 1 is to pull apart the values, show them in different forms. And later on, it's going to be very important that we take expressions and we break them down into components. It's called factoring. Okay, it won't be dealing with as much as with addition and subtraction as we will be dealing maybe more with multiplication. But ultimately, we need to be able to see the numbers within the numbers. And I explain that to my students quite often. If you see a 7, well, what other numbers do you see? Well, with 7, I see 1 and 6, right? 1 plus 6. I also see 2 plus 5. I see 3 plus 4. So again, we see these aren't necessarily factors. When we start dealing with factors, we're going to deal with numbers, and we need to know what numbers multiply to form that particular product. But again, It's the whole concept of visually grouping these things, because later on we're going to drop off the boxes and the circles. We won't be dealing with those things. We'll be dealing primarily with the numbers and the expressions, the values, the variables as they're presented. So we need to feel more comfortable with it, and that's why this lesson in particular is very important for you. Okay, now we move on to number 15. It says the expression x plus y plus 2 represents the sum of x, y, and 2. If x is 1, it can be written as 1 plus y plus 2 or y plus 3. How can x plus y plus 2 be written if x is equal to 8? So I'm going to do 1 here. Let's go ahead. Oops, didn't number this last problem. This last problem here was 13. So let's move over. I'm sorry, that was not 13, that was 14. Okay, so let's move over here to 15. And let's write that expression x plus y plus 2. And they asked us what would, or how can x plus y plus 2 be rewritten or written as, or if x is equal to 8. So let's just go ahead and write 8 instead of x plus y plus 2. Well, we have common terms here. And when I say common or like, meaning these are numbers. We can add them. We can show that expression as a value. So we would say y plus 10. Of course, we know we can write it as 10 plus y as well. Okay, so you can go ahead and do the same. In fact, the last one is going to give you both values. So you're going to just give us the value at the very end. Now, number 16, Mr. Benny is 39 years old. Okay, number 16. Mr. Benny is 39 years old. So they've given us information. Now they're going to ask us questions. Well, how old will he be in 5 years? Well, in 5 years he'll be 39 plus 5, right? That's what we would do in our head, which means he will be 44 years old, right? But then how old would he be in x years? Well, we don't know what x is, but we can certainly express it by writing 39 plus x. Similarly, the same way we rewrote 39 plus 5, we can write 39 plus x. Okay, now, how old will he be 6 years after that? Okay, so after that. Now they're saying after what? Well, after b, well, we would have to now write this as 39 plus x plus 6, right? We would just keep adding the years on. Poor Mr. Benny is getting older. Well, he would now be 39 plus x plus 6. Now again, we have these like terms, 39 and 6, which can be added. So we could say now 45 plus x. Now, we're going to go on to Mrs. Benny, who is x years old. We don't know how old Mrs. Benny is, but we're being told that, or we're being asked, how old would she be in 5 years? Well, Mrs. Benny is x years old. Just like Mr. Benny is 39, well, we'll express her age as x. And we're going to add 5 years, so that would be x plus 5. Okay, now how old would she be in y years? And again, as we did in the second one when we added x, well, we're going to add y. So we have x plus y, meaning she will be x plus y years old in y years. Now, it sounds very complex. Well, we're just substituting the value. We don't know how old she is. She's 39. And we don't know how many years you're adding, so we're going to express that as y. And we simply add the 2, x plus y. Now, how old would she be z years after that? Again, we're just going to add all of these values as they're expressed in variable form. We have x plus y, so she was x plus y years. So how many years will she be after that? Well, we add a z. Well, how many years will she be in z years after that? So now our expression is x plus y plus z. Okay, so these examples are giving you the core elements of algebra. It's something that's very important for you to master these things. Go ahead and do set 3 problems. You're going to have similar problems in this, and if you have any problems with this, you could certainly contact me, let me know, and we'll certainly try to help you out and assist you with whatever problems you have.